Hello everyone, today we will continue our talk about probabilities and its types. As we said at the last class, if we want to define the probability of any event, E, so we need the number of favorable outcomes of this event so we can divide over the number of outcomes in the sample space. And we said that the sample space by definition is all the outcomes of this event or in this experiment. So by finding this fraction, we can find the probability of this event. We said also that all the probabilities of all the events should be between 0 and 1. So basically, if we have any event with a probability equals to 0, we would say this is an impossible event. If we have an event with a probability equals to 1, we would say this is a certain event, which is 100% this event is likely to happen. When we have like 0.5 and 50 or 50%, we would say evenly likely to happen or as like as not to happen. In this class, we will talk about the probability of the complement of an event. So as we said, guys, we have sample space. And we know that the sum of all the probabilities in a sample space is 1. For example, if we have two events, when we have a coin, so the probability of having a head equals to the probability of having a tail. And if you add these two probabilities, you will get a 1. So always we have to remember that in all these events, the sum of the probabilities in any sample space is equal to 1. So based on this, we can define the complement of an event. E is all the outcomes in this sample space that are not in this event. For example, if you have a die or a dice and you want to get a face with a 3, so you would say that my event is having 3 out of 6 faces, while the complement of this event is having the other faces except 3. So this is how we define the complement of an event E. And to find the probability of this complement event, you can say the probability of having the complement of E or not E equals to 1 negative or minus the probability of the event E. So this is the formula which gives me the probability of this complement event. So let's take an example how to find the complement of this event. Let's take a look at this example. In this example, we have a total of 25 students in one of these study classes, and we have in this table shows us how many students are taken in each one of these classes. For example, we have for the French class we have 6 students, for the Spanish we have 12, for the Japanese language we have 3. So it's asking me to find the probability that if you take any random student, this random student should not be studying any foreign language. So how will you find this probability? So you have the total number, which is 25, and for each one of this class you have the number. So if the simple question was like this, find me the probability of one of the student having a French class, you would say immediately, okay, 6 over 25, because the number of favorable outcomes is 6, while the total number of the student is 25. So you would say the probability of this random student is being a French student is 6 out of 25. The same goes for the Japanese class, 3 out of 25, 12 out of 25 for the Spanish class. But the question is, I need the probability of this student is not studying any foreign language. So basically guys, if you add these two these students, you will get 21 students. So basically, how many students left? We have 25 minus 21, which is 4 students. So to find the probability of all the students not studying a foreign language, you would do this. The probability of having no language or no learning class is 1 minus the probability of having a language or a learning class. So it's 1 minus 21 or 25. Why it's 21? Because all these students which are learning languages, if you add them all, if you add all these properties, you will get 21 over 25. So basically it's 4 over 25 or 16%. We call this the complement event of another event which is not having anyone studying any class. So the probability again should be between 0 and 1. So once you get a probability more than 1 or less than 0, you would know immediately that you have a mistake. You've done a mistake in one of the calculations. Let's take another example. In this example, guys, we have to choose two integers out of 10 random numbers between 1 and 10. And we can choose this number twice. So he's asking me to find the probability that these two numbers are less than 9. For example, 1 and 3, 3 and 4. So how to find the probability of this event? If you want to find the combination which gives you less than 9, so you would say I have 1, 2, 2 and 3, 3 and 4, 2 and 2, 1 and 1. So either you would calculate or count all these probabilities and then you would find the sample space, the whole sample space, or you can use the complement event. How? So I need the probability of this number less than 9. Okay, which is 1 minus the probability of this number bigger or equals to 9. So how to find this? So how many numbers do I have bigger or equal to 9? So basically I have only two. I have 9 and I have 10. So it's only two numbers. So out of this or these numbers from 1 to 10, I have two numbers bigger than 9, which is 9 and 10. So that's why I wrote 2 out of 10, because the sample space in this case is 10 numbers, while the favorable outcomes for this event is two numbers, which are 9 and 10. So that's why I wrote 1 negative 2 over 10 gives me 8 over 10. So basically this is true because you know that, by the way, we can find the probability of having a number less than 9 by just finding all the number less than 9, which are in this case like from 1 to 8. So basically we have 8 outcomes, so we can write 8 over 10 immediately. So this is for one number, guys, because I'm asking you to find the probability that both numbers are less than 9. So this is for the first one, and the second one, see, because I need two numbers. The second number, I have the same process, the same calculation. So I would write for the first number I have 8 over 10, and this multiplication, because it's written both, this means and. So in probability we can transfer and into multiplication. So 8 over 10 multiplied by 8 over 10 equals to 64 over 100 which is 64%. So the probability of having two numbers, each one of these numbers less than 9, so I have to take the probability of each one of these numbers multiplied by the other. I will get the probability of the event. Thank you guys, hope you enjoyed the class.